Good day, Algebra. Continuing PO55. We started this basically talking about how to solve a quadratic equation. And when we say solve a quadratic equation, what do we mean? When we solve for a parabola, what's it asking us to find? If you started with Khan Academy, they also call them roots. Find the roots or the zeros. We're solving all those things mean we're looking for the x-intercept. Exactly. Okay. We talked about when a parabola might have two x-intercepts, one x-intercept, or no x-intercepts. And then we started here with this first type of an equation, ax squared plus c. There's no bx term. Because we only have one x variable, we can use order of operations. Okay, the opposite operations. Our x-intercepts will be opposites, and we did these three as examples. So let's just review this briefly. Flip to PO55 part 2. Okay. And let's look at a couple here. Now, the first one, 6x squared minus 96 equals 0, that kind of looks like what we did the other day. It equals 0, which we want. We want the y value to be 0, because that represents the x-intercept. Let's talk about this one. This one can kind of throw people off because it doesn't equal 0. Okay? But it's still in that ax squared plus c form. It's just part of the constant has already been moved over to the right side. Okay? If you wanted to, you could subtract 480 from both sides and write it as 4x squared minus 400 equals 0. Right? But then what would your next step be anyway? Using opposite operations here. Connor.
Add 400.
Add 400 right back to that right side. Right? And you ultimately end up with 4x squared equals 400, and then you'd go from there. Okay? You might also notice that in this first step, instead of going through all that, what would you do if you were given this equation and asked to solve for x? What would your first step be anyway? Subtract 80, right? Move that constant over, and you'll find that either way, you get 4x squared equals 400, right? So if your equation doesn't equal 0, it might not be a problem if you're doing the opposite operations method anyway. Whether you move the 480 over and then move the 400 back, fine. Or start with your constant, subtract 80 from both sides, and you end up in the same place anyway. Okay. But anyway, where do we go now from here? What would our next step be? Opposite operations. Look back to your notes from Thursday, or just think about solving an equation. We took care of the constants. So now we would move to Connor?
Divided by 4.
Divide by 4. Okay. And we get x squared equals 100. Now we've got that x squared piece, and this is where we bring in perm dots, and we say the opposite of squaring something, the opposite of an exponent, we now get to Annika? Root both sides. Exactly. Okay. The square root of x squared, these operations cancel out. They're opposite. We're left with x by itself, but it's not good enough just to put x equals 10. Since we're talking about a parabola, and we know they can have two x-intercepts, and this is the type of the equation that we have, you look back at our notes and we say that our answers will always be opposites. What do we do? Yeah.
10 negative 10.
Right. 10 and negative 10. Okay, you need two answers here. You need both a positive and negative value of 10. If you didn't want to write that, 10 and negative 10, what could you use instead? It's a cool little math symbol. Yeah. Right. It's that plus minus sign. That means positive and negative 10. Either way would be acceptable. Okay? Either way would be acceptable. So that's what we did on Thursday. We looked at this type of equation. We talked about opposite operations. We set y equal to 0. We solved it, and we got the two values for the x-intercepts of our graph. All right. Today we're going to look at the other forms that a quadratic equation could be in, starting with ax squared plus bx. Okay. So this time there's no c term, right? There's no c term. And why can't we use opposite operations here, like we could in the previous form? there's two x terms that can't be combined. We can't add x squared and x together. They're not like terms. And because of that, we can't solve for x. We can't get x by itself because those aren't combinable. So in this form, your method is factoring out the greatest common factor. You'll find that this ties into PO50, where we divided by monomial expressions. It was on your last test. And the hint for this one, you'll always get two solutions. One of them will be 0, right? So you already got one peg, 0. So let's take a look at this. Solve each quadratic equation. Check your answer by plugging back into the equation. Y equals 10x squared plus 30x. We're going to start by setting this equal to 0. And our method being factoring out the greatest common factor. What's the greatest common factor of 10x squared and 30x? What can we take out of both of those terms? Connor? 10x. 10x. Okay? 10x goes into both 10x squared and 30x. We first looked for greatest common factor back in objective 44, I believe it was. Okay? But when we take out that 10x, in parentheses, we put what's left. You also kind of did this back in PO52, where we factored out the greatest common factor before factoring, going through that 7-step process. So if we take a 10x out of 10x squared, what is left? Take a 10x out of 10x squared. Mathematically, it's like we're taking 10x squared and dividing by 10x. What would the answer to that be? 1x. Just x. If you want to write the one you can, but just x. And then if we factor out a 10x from 30, or mathematically, 30x divided by 10x, what are we left? 3. Okay? Now remember, this expression now equals what? In order for this to be an x-intercept, what does this expression equal? 0. So what we're looking for now is we are looking for the value or values for x that makes the expression equal 0. Okay? And since we're multiplying this quantity 10x by that quantity x plus 3, our goal is essentially what value for x makes 10x equal to 0. Right? Because if we set 10x equal to 0, what would x be for 10 times x to be 0? 0. Remember, one of your answers is always 0. If we set this equal to 0, does it matter what our parentheses equal? No, because 0 times anything is always going to be 0. Okay? So that's where your freebie comes from, is when you factor out that greatest common factor, this first answer will always be a 0. Because 10 times something to equal 0 will always be 0, and 0 times whatever bring us back to 0 we want anyway. Okay? Our second expression, x plus 3, what value for x makes x plus 3 equal to 0? What would we plug in for x so that when we add 3 to that, we get to 0? Okay. Good. Our second answer is -3, our second x-intercept. Because if we plug in -3 into this set of parentheses, it equals 0. Does it matter what this equals out on the front if this equals 0 and we're multiplying them? No. Because 0 times anything is going to equal 0. So your two x-intercepts come from the values that make each expression, what's out in front and what's in parentheses, equal to 0. I'll let that sink in a little bit. Okay? Any initial questions? Okay, let's look at the next one. Y equals 6x squared minus 15x. We're going to set that y equal to 0. And our first step is to factor out the greatest common factor. What goes into both 6x squared and 15x? Anyone that hasn't participated yet today?
3x.
Good, 3x, okay? And if we take a 3x out of 6x squared, what are we left with? Essentially what you're doing is you're taking 6x squared and dividing by 3x. What does that divide to be? 2x. Okay? And now we go to our negative 15x, and we're dividing negative 15x by 3x. We're factoring out that 3x. What are we left with? Negative 15x divided by 3x. Aiden? Good. Not negative 5x. These x's would cancel out there. They each just have the 1, right? So we're going to be left with negative 5. Okay? So we have 3x times 2x minus 5. And you can check to see if you're correct here by distributing the 3x back into the parentheses, right? 3x times 2x gives us 6x squared, and 3x times negative 5 gives us negative 15x. That's a good way to check, make sure you've done your math correctly. Distribute it back in, see if you got what you originally had. And of course, this equals 0. So just like before, we're looking for what the value for x makes each expression equal to 0. What value for x makes 3x equal to 0? Everybody, in unison, what's the freebie?
0.
0, right? 0. That will always be your answer for the greatest common factor that you pull out of there, 0. This one is a little bit trickier. 2x minus 5. What value for x makes 2x minus 5 equal to 0? Not quite as much of a mental calculation as it was here for x plus 3. But what method could we use to solve this? If we want to know what x value makes this equal to 0, we set it equal to 0, and what do? We solve the equation, right? We know what we want 2x minus 5 to equal, and what we want it to equal 0. And so let's just solve for x. Add 5 to both sides. We get 2x equals 5. Divide both sides by 2. And we get x equals 5 over 2. I'll write that over here so the words don't block it there. X equals 5 over 2. And 0. So sometimes you can just do it in your head if it's something like just x plus 3. Other times maybe you can't. It's more complicated expression. You can still, knowing you want that to equal 0, set it equal to 0, and solve for x. What value for x makes equal 0? 5 halves. And those would be the two x-intercepts of our problem. Right? Makes perfect sense, right? Jacob?
Where'd you get the 2x in parentheses?
The 2x came from when I factored out that greatest common factor of 3x. When I started that 6x squared term, 6x squared divided by 3x, this x cancels out with one of the x's in the numerator, but I still have one left. And then 6 divided by 3 equals 2. Right? So in expanded form, it's like 6 times x divided by 3 times x. One of the pairs of x's cancels out. I've still got one left. And then 6 divided by 3 equals a 2. So that's where it came from. Connor.
Is the second x-intercept 5 over 2?
5 over 2. Yep. 5 halves. Yes.
So it's x not equals 0 and x equals 5 over 2?
Correct. Those are our two x-intercepts. Yeah.
So you shouldn't make it a decimal?
If you want to make that one into a decimal, that would be okay, because it's 2.5. It ends easily. If it's one that you'd have to round, then leave it in fraction form. Yeah. Like the next one, okay? Y equals negative 14x squared plus 9x. Again, we're going to start by setting this equal to 0. Make that y value 0. That means we're solving for the x-intercept. And what is our greatest common factor of negative 14x squared and 9x? Fourteen and 9 don't share any factors other than 1. We can't really factor out a 1. Nothing really changes. So what's our greatest common factor going to be? What do both terms have that we can take out? Yeah. They both have an x. Okay? At the very least, you'll always be able to take out an x. Because by definition, this form, both terms have an x. Okay? If they don't have an x, then you're not dealing with this type of equation. So at the very least, you can always take out an x. And if you take an x out of negative 14x squared, what are we left with? Negative 14x. Just one of them, right? Welcome. You take an x out of 9x, what do we have left? Somebody haven't heard from me before. You can do this. You take an x out of 9x, what is left? You find 9. Right? So we're left with negative 14x plus 9. And again, you can double check this by taking that x and distributing it back in. X times negative 14x is negative 14x squared. X times 9 would be 9x. Okay? So now we're looking for what value makes each of these expressions equal to 0. What value for x makes x equal 0? There's our freebie, right? X equals 0. The other one, again, a little more complicated expression, but we're looking for what value for x makes negative 14x plus 9 equal to 0. And just like in the last example, we can solve this equation using opposite operations for x. And that's going to tell us what value for x makes it equal to 0. So we'll start by subtracting 9 from both sides. So we get negative 14x equals negative 9. Divide both sides by negative 14. We get x by itself. And how does the fraction negative 9 over negative 14 simplify? Positive 9/14. Yeah. The only thing we can cancel out or reduce are the negative signs. So we have x equals 0 and x equals 9/14. Okay? This is a fraction you want to leave in fraction form, because if you divide this out, 9 divided by 14, you get a nasty decimal that you have to round, right? And we don't want to do that. So you would want to leave this in fraction form. Okay? All right. Any questions or comments, connections, observations, things that stand out to you as being, that's kind of interesting. I wonder if... Anything? I am hinting at something. I am, yes. No? Okay, well, we'll do a couple more, and we'll see if anything surfaces. Yes, Morgan?
I know, but I don't know how to explain it.
Point out what you're noticing, and I'll take it from there.
The 5 over 2 is like 15 over 6.
Okay, so Morgan's noticing, and you actually went one step further than I was planning on initially, so steal my thunder, but thank you, okay? Notice here that our final answer, 5 over 2, do those numbers look familiar? Maybe? 5 and 2? Or in our next one, 9 and 14? Those come from anywhere, maybe? Are you seeing any relation? Yeah, go ahead.
Earlier in the equation.
Sure. 2 and, albeit a negative 5, were in our parentheses, and we somehow went up with positive 5 over 2. Interesting. Here we had 14 and 9, negative 14, and we went with positive 9/14 as an answer. It seems that if we have a parenthesis expression of ax plus b, just picking values there. What position does this number end up being in our final answer?
The numerator.
The numerator. The numerator. And what position does this number end up having in our final answer? The denominator. And one more thing. Here we had a -5 and a +2. It ended up being +5/2. Here we had a +9 and -14. It ended up being +9/14. There's one little thing. Whatever this constant is, it's the opposite of it. So here we had a -5. It ended up being +5/2, the opposite of b divided by a. Here we had a +9. It actually still ended up being -9 here, right? But then because we divided that by our -14, it made it +9/14 anyway. So there's a formula for this. Isn't that nice? Your two answers for the x-intercepts of an equation in this form, one will always be 0. That's a freebie. And the other one will always follow the formula -b/a. -b/a. Not to be confused with our vertex formula, which is -b/2a, right? So if you put these formulas on a help sheet, you want to identify what goes with what. Okay, it's very, very similar. But there is a much shorter way to do this than what I laid out. And there it is. No applause, no standing ovation. No. Next time we'll keep these secrets to myself then. All right. Let's look at something to practice with. Let's go to 56x squared plus 8x. Following our little shortcut that we just talked about from up above, who can already predict what our two answers are going to be here? And maybe we want to start by factoring out that greatest common factor first. What is the greatest common factor between 56x squared and 8x? What can we take out of each of those? Yeah. Take out an 8x, right? Always that x. Always that x. And if we take out an 8x from 56x squared, what are we left with? Connor?
7x.
7x. And if we take out an 8x from 8x, what are we left with? But be careful, because the answer isn't 0, right? Because mathematically what we're doing is we're taking 8x and we're dividing it by our greatest common factor, 8x. What would that expression equal? 1. 1. Okay? Not a 0, it'll be a 1. Because if you distribute 8x back in, 8x times 1 gives us our original 8x, whereas 8x times 0 would be 0. Right? So it is going to be a 1. All right. Now, who can predict what our two x-intercepts are going to be? Using our shortcut from earlier, because that's just too much fun. Huh?
0 and -1/7.
0, there's the freebie, right? And our second one comes from this. Let's pretend this is an ax plus b form here. Our formula is the opposite of b, or the opposite of our constant. That's going to be -1. Divided by a, our coefficient, that's going to be 7. -1/7 is correct. Isn't that nifty? Isn't that fun? Come on, go drink water.
Yeah.
Okay, you go ahead. Okay. Questions on that? Comments, concerns, complaints, compliments? Well, there you go. All right. Next one. What can we factor out of both a 2x squared and a -13x? Someone we have not heard from yet today. I want a new voice. What can we take out of both 2x squared and -13x? Just x, exactly. 2 and 13 don't share any factors, so just the x. And if we take an x out of 2x squared, we're left with a 2 and 1x. We take an x out of negative 13x, we're left with a negative 13. And that equals 0. So, now, here we have our freebie, right? What's that one going to be? Always, Morgan? 0. Okay? And this one, we can use our ax plus b and the formula negative b over a. What's our other x-intercept going to be? Again, a new voice would be phenomenal. Did you get it? Good. You already participated. Yeah. We can do this. We're using our formula, negative b over a. This is in the form ax plus b. Here's our b value. Right here, we want the negative of that, or the opposite of that. What's that going to be? I heard from you today. Thank you. Someone new. The opposites of a negative, yes.
13 over 10.
13, the opposite of a negative 13 will be a positive 13. And then we're dividing that by our a term, which you don't have to do anything to that. That's just straight up what it is, 13 halves. So x is 0, x is 13 halves. Okay? What's quote unquote wrong with the next one here? Or what do we have to do first before we do this super fun shortcut thing here? Connor.
Move negative 12x over.
Yes, we have to move negative 12x over. And in just going through practice work and retakes recently, when you have to move a variable term from one side to the other, there's still some that are just taking that negative 12x squared and plopping it over on the other side as a negative 12x. Okay, when you move a term from one side of the equation to the other, you've got to be using opposite operations, meaning we're going to be adding 12x to both sides here, right? And even though we can't combine that 12x with 6x squared, that's okay. When we move it over, it's going to be a positive 12x. When you move an x term over, okay, or any term over with addition or subtraction, the sign has got to change. So 6x squared plus 12x equals 0. Now, what can we factor out of both of these terms? Greatest common factor of 6x squared and 12x. Someone new. Heard from you. Thank you. Yes. 6x. 6x. Okay? And if we take a 6x out of 6x squared, we're left with just the 1x. If we take a 6x out of 12x, we're left with a positive 2. Now this is one where you wouldn't have to use that shortcut because this is kind of one of those more mental ones. You just kind of see what makes that x plus 2 equal to 0. We'll do it anyway because it's just fun. Our first one, our freebie, the 6x, x equals 0. Our second one, I mean, just to further prove that this shortcut works, let's look at it as ax plus b and use our formula negative b over a. Our b value is positive 2. And so the opposite of that, the negative of that, is what? Negative 2. And our a term, even though it's not written, is a 1. Negative 2 over 1. is the same as -2. And hopefully that's the answer that you all got by looking at it. What value for x makes that 0? -2. But the formula holds true. It works. We got -2 as an answer for that one as well. Okay? Questions on any of this? We didn't make it to the third form. That's okay. We'll do it tomorrow. But so far you've learned about, don't back up yet. So far you've learned about ax squared plus c, which is opposite operations. We did that one on Thursday. Now you've got ax squared plus bx. You've got factoring up the GCF or this fun little formula. Okay. Your homework for tomorrow is on PO55 part 2. This set here. Okay. These 6. This goes back to ax squared plus c. So you're using opposite operations. And you are looking for 2 opposite values. And then we already did these 3. On the next page, you've got a set of 3 to do here. That's in that ax squared plus bx form. So 9 total questions for tomorrow, all in PO55 part 2. 6 of them are in ax squared plus c form. And then these other 3 on the next page, ax squared plus bx form. Okay? All right, so there you go. That's how you math. Like and subscribe. All the things.